Fantastic. So next in our lineup is Camélia. So I wonder if I could ask Camélia to turn her video on and unmute her microphone.
Good afternoon, everybody, or good morning, according to your location. I will share my screen with you. Hopefully you can see it. Okay. Peter,
that's fine. I wonder if you just want to, I can see it. I just wonder if you can, yeah, go to screen show.
Screen show, yes.
Great.
So before starting my presentation, I would like just to speak some words about AGC company. AGC is a worldwide company producing glass for building and industrial application, also for automotive glass, electronics, and chemicals also. The AGC is present over 30 countries through 210 companies with more than 55,000 employees and 12 billion of sales. The headquarters is in Tokyo, and we are present more than 30 years in Middle East. Our fire-resistant glass branded Pyrobel is produced in Europe in 3 production plants, and is in Belgium and Czech Republic, and is distributed through a network with more than 100 distributors. We have 3 fire testing furnaces, and we perform more than 100 tests a year. And we have sales representatives in Europe, Middle East, Africa, and North America. And now let's go to the presentation. Today I will speak about the fire-resistant glass as a passive fire protection. I will explain why we use to need fire-resistant glass, how the glass is assessed, what are the different types and technology for fire-resistant glass, the different application, and which other characteristics we can combine the fire-resistant glass. The glass is a beautiful material when you need to combine light and aesthetics in a building, but as the safety, it's even more important than the aesthetic. We as the glass manufacturer, we had to develop a safety fire-resistant glass. The glass, the passive fire protection principle is that you have the building compartmentation in fire area. As you can see on the drawing here, you see fire area A, B, C, and the red lines are fire-resistant partitioned and doors. This compartmentation allows to keep the fire in the area where it ignites, also to protect the people and the goods, and to provide escape routes to the people living in the building and safe access to the fire brigades to extinguish the fire. We can have a fire compartmentation on the same level. You can see this on the left drawing, and on the right drawing we have the same separation between different levels, floors in a building. How we assess the fire-resistant glass properties? There are standards, EN, BS, UL. The glass installed in a frame, the element glass plus frame, it's installed in the front of a furnace, and then a heating curve which simulates a real fire is applied to this glass. The heating curve is quite similar for all type of standards. What is a bit different is that we have for UL standard, the hose stream is applied at the end of the test on the glass. EN standard has different thermocouples to pilot the furnace, but they are quite similar. On the other hand, we have the building regulation, which determine the level of protection you need in a building according to the number of people, the height, the neighborhood, and this is a national competence. Each country has its own building regulation, and the national authorities, for example, in UAE is civil defense. In Europe, in Belgium, France, we have Ministry of Interior as a national authority competence. According to the results from the fire test, the glass is classified in different class. The three fire protection classes are: the first one, E, integrity. So the glass stop the flames and the smoke, but all the heat is passed through the glass. Then we have the second class, EW, integrity and low radiation. The element will stop the flame and the smoke and will limit also the heat transfer to maximum 15 kilowatts by square meters. And then the most protective class is the EI, integrity and insulation. So the element will stop the flame, the smokes, and also will block the heat transfer. So people present in the building can be evacuated without panic and quietly. Now I will speak about the different technology, different type of glass present on the market. We have first the wired glass. It's a glass with a wire mesh embedded in the glass during the fabrication process. This glass is in a E class. The main advantages is that it's a cuttable glass, so it can be produced in stock, so you will have a good service. The thickness is quite good, no thick and heavy glass, and it is the cheapest glass on the market, but there are some drawbacks also. It is in the lowest fire protection class. Aesthetic and transparent are not so good also. It is not a safety against fall glass, and due to this, it has to be in small dimension. We can find this type of glass in industrial doors as oculus mainly. A second category, it's a toughened coated glass. The toughened glass, it's a heat-treated glass, and this heat treatment gives to the glass a better resistance to breakage in case of thermal shock. We can have also a thin metal oxide coating on the glass, and these two types of glass are in the E and EW class category. The advantages are the thickness and the low weight. There are no problem of aging with this glass, and this is safety 1C1 class. But it's in the low fire protection class, the medium dimension for application. As it's a tedious installation, it's quite sensitive. If you have during the installation the lowest scratch on the glass, then the glass will break during the first 5 minutes of the fire and will be not more protecting. A third category is ceramic and borosilicate glass. These are both resistant to fire thanks to their low expansion coefficient when heated. This is for ceramic glass thanks to its special polycrystalline network. Normal glass has an amorphous composition. And for the borosilicate is thanks to the special chemical composition. It contains some boron trioxide in the composition. Both class are in the E class, integrity only. So the main advantages are that they are long duration resistant to heat, so they can stand 3-4 hours in a fire because they will not expand and they will not break. They have a good aging, there is low thickness and lightweight, but the fire protection is low. They are quite expensive glass due to their special structure and composition. They are used in quite limited dimension, and for borosilicate glass we have a brownish color. And then we pass to the most protective glasses, EI class. In this category, we have laminated annealed glass with intumescent interlayers. How is produced this glass? The intumescent liquid layer is poured on the glass, on a sheet of glass. Then it's dried in order to obtain a hard and transparent interlayer. And then all these glass plus layer are stacked on top of each other in order to obtain multi-layered glass with 2, 4, up to 10 layers in a glass according to the rating we can reach. And how this glass is working in case of fire. The intumescent interlayer contains a limited quantity of water, and when the temperature on glass increases to over 100 degrees, this water starts to boil, which activates the foaming of the layer. This evaporation or boiling of water, it's an endothermic reaction which will absorb the heat and will cool down the glass. And with the foaming, the interlayer will turn into opaque and resistant fire barrier. Advantages of this kind of glass is the highest fire protection. It's a cuttable glass. It can be produced in stock size, so a good service. The aging, there are no problem of aging, is a good. The main drawback is that the intumescent interlayer is sensitive to UV, and for external application, an UV filter is needed. And the last but not least category, it's laminated toughened glass with intumescent gels, also in EI category. The toughened glass is assembled in an insulated glazing unit and the cavity is filled with an intumescent gel. And we can have two types of gel, inorganic silica-based gel, and for this category we will have multi-chambered glass according to the rating we want to reach. Or we can have an organic gel and polymer based, and then we will have always one chamber thinner or thicker according to the rating. The action principle during the fire is the same with the foaming gel. The advantages is the highest fire protection. We can produce very big dimension of glass up to 5 meters. It's the inorganic gel is UV resistant, and the organic gel is low weight. The main drawbacks are that is only in cut size available, and this will lead to longer delivery time. And organic gel are quite sensitive to UV. They become yellowish during the aging. The fire-resistant glass is present on the market for about 30 years now. At the beginning, we had a small glass dimension with big and massive and thick frames to maintain them. But during the time, this evolved into slimmer and slimmer frames and with bigger dimension of glass. This is due to the request of architects for more aesthetic reason. And today we can have, you can see on the picture on the right, a very nice glass partition with both jointed glass supported only on top and the bottom by a frame and jointed vertically by a thin silicone joint. We can use the fire resistant glass in all type of application in a building as glass partition, doors, curtain walls, roof and floors. You can see here in a couple of pictures with all these type of application. We as glass manufacturer, our priority is to reduce our carbon footprint. The glass performances allow to construct carbon-free buildings and smart, sustainable cities. My recommendation to you today is to verify sustainability when you choose your fire-resistant glass via labels like cradle to cradle, life cycle analysis, or volatile organic release. The fire-resistant glass can be combined with other performances in order to meet all the architect's whims. We can have thermal insulation by assembling the fire-resistant glass in a double glazing unit and triple glazing unit. We can combine it with acoustic insulation by using acoustic films. Safety against fall and resistance to loads. Also, we can combine with security, burglary, bulletproof, explosion, and of course with aesthetic by using decorative films, silk screen printing, or colored glass. A lot of possibilities available for fire-resistant glass. And then I will show you some picture reference realized with Pyrobel. Here we have the Aerospace Center in Singapore, a glass partition with Pyrobel. Then we have a nice building with butt joint glazing systems, the UNICEF headquarters in the Netherlands, the Brussels airport connector, facade in the Netherlands building. And this was my last slide. I want to thank you for your attention, and before giving the floor, I would like to thank you to the organization of the Fire Safety Forum to give me the opportunity to speak about the fire-resistant glass as a basic protection. And I invite you to visit our booth in the exhibition area. Thank you.